Hi everyone, my name is Prashanto Kochavara. I'm the Director of Product at Trilio. Today I'm going to be providing a demonstration of the Trilio Vault for Kubernetes user interface. What you see in front of you is the Trilio Vault for Kubernetes user interface landing page. The landing page has been divided into three sections. On the left-hand side, we have the cluster navigation section. In the middle of the screen, we have the application discovery section. And then on the right-hand side, we have the monitoring section or the monitoring panel. I'm going to talk about each of these panels or sections from left to right. So talking about the cluster navigation panel is where users connect multiple clusters where Trilio Vault for Kubernetes has been installed. Adding a cluster is as easy as clicking the plus icon here and providing a kubeconfig file. What this means is we leverage the existing permissions and policies that have been assigned to a user based on their Kubernetes permissions. And we are not really creating anything new. So the experience of the user interface remains the same, and a user only sees the objects or the namespaces and the resources that he is entitled to. Coming to the center part of the screen, we have the application discovery or the application selection section, which has been divided into multiple views to make it easy for the user to select the applications or the objects that he wants to protect. So the first view, based on application tooling, shows you all your Helm and your operator-based applications. The next view is the label-based view, which consolidates all the labels within the namespace that has been selected in the navigation panel and provides that as an option for the user to choose from. We also provide objects, independent objects, which could be just secrets or persistent volumes that the user can select as well. And then finally, we provide the feature of defining your own backup plans, which can be a combination of any of the items from these three views. The user also has the ability to select a backup plan and further concatenate it with any of the items from any of these views that have been provided. A green border around an application shows that it has been protected. It has at least one successful backup. The red dot or a yellow dot or a green dot on top signifies that the last backup was either successful or is in progress or has failed. Similarly, the time icon shows if the application is protected by a schedule. And then finally, the box icon or the squarish icon here shows that a restore has been performed based on a backup of that application. Any of these filters can be, filters or layers can be applied and taken off as the user thinks necessary. Now coming to the monitoring view of the landing page, this is where we provide a backup summary, restore summary, target summary of what the user has selected either at the cluster navigation level or depending on what the user has selected in the application discovery panel. When you select an application, the backup summary, restore summary, and the target summary automatically reflects backups, restores, and storage space occupied by that particular application backups. A user also has the ability to go into the details panel and see what is the metadata that is being collected as part of this application. The user also has the ability to dive deeper into backup summary or restore summary and take a look at all the backups that have been happening in a particular namespace or concatenate that with multiple namespaces to get a fuller picture. The user can also click on a particular backup, understand the steps that were taken as part of the backup, and if any of those steps had failed. Via the status log, all that information is provided at a very granular level. The user also has the ability to take a look at the backup plan summary, which specifies where the backup was going into, what target, if it was using any hooks or it was using any policies, and so on. The user can also take a look at the metadata to understand if all the objects that he was interested in were captured successfully. He can dive deeper into the metadata to see what are the different objects that are being collected, as part of the metadata components, as part of the data components as well. This information is very useful to the user because when he's doing a restore, he can leverage all this information and apply a restore transform on the metadata object. So for example, if he wants to change the storage class when it's going or when the application is being restored into another cluster, the user can do that as well.